into a rut whereby they will be taken over eventually because they're just keeping what they have. They don't have the ability to pivot anymore. They can only get saturated, so to speak. So that's what we've done. We've had some pretty okay videos, and we've also had a guest speaker in David Garnett, who was there in the room where it happened when they actually started this whole computing technology, which I didn't know till last week or 2 weeks ago. Computing technologies, much of it came from Xerox because they were not willing to pivot. They just kept it on the shelf and eventually sold it to Microsoft and to Apple. So they watched them grow because they wanted to sell copiers. So class, tonight we have a special guest. Allow me the opportunity to introduce. I would like to introduce Sophia Rodriguez, my daughter. I'm happy to say so. She's an amazing young lady. I think she's one of the persons I truly look to see how and where we are moving and how we think and how we move ahead. Sophia has been, and she can tell much of it herself, but for me, she's just been a shining light for me, and I've seen for many others too. She's been my guest in other lecture series, and this one, I hope she could impart upon you some of her information she has, and I hope she can tell you a bit about yourself. So, Miss Sophia Rodriguez, please introduce yourself. We have until our class literally ends at 8:30. The floor is yours. I'm going to minimize myself. My class members, I'm sure they're giving you shout outs in the chat. But let me see, Robin is here, and we have the classes here. And this is being recorded. At the end of the recording, it's okay with you. We trim it, and we only keep your portion, and it's posted to class and to YouTube. Miss Sophia Rodriguez, please.
Hey, thank you so much, Dr. Rodriguez, for having me here on the class. It's so interesting. The last time I did a class with this group or at Texas Southern University, I was there in the Barbara Jordan Mickey Leland School of Public Affairs. I was in one of the auditorium rooms. I also did a class upstairs in kind of one of the smaller classrooms. But now in this new normal during the pandemic, you know, I'm happy that I'm able to also now give a digital presentation. Again, Sophia Rodriguez, I have an undergrad in environmental policy from the University of Tulsa in Tulsa, Oklahoma, where I also competed in track and field. Feel free to Google me, still have the school record. I'm gonna always say that. So just that. I have a post-baccalaureate certificate in GIS from Penn State University. I also have a master's in GIS from the Johns Hopkins University, DC campus. I've been working at Boz Allen Hamilton now for 11 years in 22 days, but who's counting? I was able to start with that company in San Antonio, Texas, then moved on to the DC metro area for, I was in Texas for 3 years, in DC for about 5 years, went over to Hawaii for a year, back to DC for a year, and now I'm back in the state of Texas and really enjoying it. I think one thing that's really helped me stay up with market trends and allowed me to move around so much is probably networking and always being up to change, being agile, not just being stuck or staying with things that always used to work. My understanding of this class is in regards to computer science and application. So what I'm hoping to show today is some of the technology my group is working on. We are trying to bring our civil agencies and our defense agencies kind of into the future. How can we go from structured data, think Excel spreadsheets and scribbled notes on papers, or even Word documents, to unstructured data where you're even just speaking, or real-time information, real-time sensors, even Twitter feeds, or, you know, think of social media, that's very real-time. How we can begin to parse that information, analyze it, and visualize it for different leaders for decision-making. So I'm hoping in terms of objectives of my speaking, you'll be able to see some use and integration of different systems, of different computer applications. And I can't see any chat or anything, so I hope there'll be questions at the end, or maybe someone could, I don't know, point to me how I'm supposed to see them. This is probably the first briefing I've done since pandemic where I can't see any other people. So I'm literally talking to myself, which is kind of odd. I tried to pull up the slides before and the videos weren't working when I just pulled up in PowerPoint. So I'm going to be sharing from File Explorer. I apologize, but I can definitely share the PowerPoint or a short video with all of you, a link that you can you guys can go watch on Vimeo. This will be a bit of a longer version of that video, but you can get the drift there and be able to have it with you for reference in the future. Okay, sharing my screen. Sure. I want to work up there. I'm just going to keep it down here then. Here we go. Sorry about that. Screen one. Okay. Can I get a confirmation that you can see the screen, Advanced Infrastructure Solutions?
Yes, screen is being seen.
Okay. All right, let's press. So, Boz Allen, our tech infusion products and services. I think it's important to note that right now the government is in need of consulting services, of smart people like you guys on the line today. What we're doing, and everyone kind of out there in the A&E firms are doing, are master planning, preliminary design, construction management, facility utility management, as well as some engineering and power engineering. What our team, our solutions group, is trying to bring to the table are more innovative services. So just think of the services I just mentioned, but we're trying to, really push those into the future. I'm hoping that our clients can adopt technology, do more design thinking, do more innovation cells, accelerators to get their products to market more quickly, efficiently, and bringing more value to them. Our two products I'm going to talk about today, where we are using different computer applications, is the autonomous infrastructure management, and we use AI for that, as well as a digital twin. And digital twin is a connection of several data types. We have the baseline being Esri, ArcGIS information. We're using Revit models and AutoCAD, InfraWorks 360, as well as the Internet of Things and real-time sensors. So we have real-time sensor feeds, all being brought together in an integrated platform that we call the digital twin. This slide is really just to kind of show the progression and workflow of the integrated platform. We're really trying to drive this type of technology into construction, sustainment, and operations. One thing that we are trying to showcase to some of our clients is how you can use data you already have and just do a little bit of retrofitting to begin to help you in expand the lifespan of different critical infrastructures. May that be a building, may that be an HVAC unit, even reducing time on things you have to do on an annual basis, like environmental impact statements or different NEPA reviews for new construction. This workflow, this is kind of the baseline of any of the use cases I'm going to talk about today. So I'm going to sit on this slide just for a little bit. So it goes from left to right, and it's really simple. We capture data, we analyze data, we visualize data, and then we use that visualization to help us with studies, forecasting, and simulations. So in the capture, or one, using autonomous systems, think of that portion as the baseline. So we're using, like I said, GIS, different sensors. We're flying drones. We have handheld monitors. We have iPhones, tablets. We're using different platforms and different sensors to do continuous and periodic picking up of information. Next in the process, you have to then analyze the information. We call that our artificial intelligence and machine learning engine. Really important to note, this engine is at a high speed, constantly ingesting this information. We're doing a lot of our analysis on the edge, so like edge computing. So it's kind of like the computer sees data and analyzes data and gives you an answer right in space, as opposed to an upload into a cloud, download back to your machine. We're doing everything in the edge. And this is a part of that real-time Internet of Things predictive analysis. The digital twin, or that integrated platform, is now kind of the culmination of us capturing and analyzing. Now we want to build out a twin usually in a digital space that users can interact with. That could be using mixed reality, that could be using virtual reality or augmented reality. And you'll see some examples about that, or we build out complete buildings in a gaming instance where you can then do different simulations and see different ways you can do analysis. And that analysis, again, can help senior leaders, executive leadership. I'm thinking of even if you were to build another campus. I mean, just build it out in a 3D or 4-dimension space first, and you can begin to move buildings around. So if this is going to be the quad area, and this is going to be where we are going to have our engineering buildings, what's going to be the traffic flow? Where should we put the parking lot? Where are our students going to go eat and then come back on campus? Where should we potentially have exterior lighting so there aren't any public safety issues? So this could just be done in an as-built drawing. It could be done, again, just using pen to paper. But when you do a digital twin environment, you can literally go through scenarios instantaneously based on data that you've already captured and analyzed. Now I'm just going to walk through, again, those 4 things with a few examples. This is showing some of the autonomous systems. These are different contracts my team has worked on. See the National Park Service, the Army Corps of Engineers, the Air Force, the Veterans Affairs. And what we're trying to showcase here is that we are using autonomous systems in all of these instances, drones, to capture information. Currently, it's done conventionally. People are on the ground with pen and paper or tablets, taking pictures or documenting and annotating what it is they're seeing, or going through checklists. We can begin to feed the same requirement of pictures, the same checklist, onto a autonomous system and get over 10 times as much of the study area done in the same amount of time. In that lower left-hand picture, it's showcasing basically what a flight navigation would be for a drone. So there's not ever going to be we put the drone up in the air and we didn't get the entire shot of the roof or of the pavement or of that area of concern. You build out your flight plan before you go up there. And now we're talking about the sensors on the autonomous system. So the West LA campus, upper left-hand corner, this is a LiDAR scan of this facility. This was 300-acre facility in LA, or outside of LA. And they originally asked us to do a tree study. That's it. Can you guys come out and do a tree study? We'll give you two months. We know you have to bring out your horticulturalist and your tree specialist and an engineer. We decided to provide them with an innovative solution and say, hey, we will do the tree study. It will take us the weekend, Saturday and Sunday. While we're up there, we'll go ahead and scan your roofs, scan your pavements, and give you an entire environmental impact study. Again, when you have drones, you can put different sensors, may it be RGB, photogrammetry. You're obviously picking up full motion video, LiDAR capture, thermal imagery. You can do several pieces of analysis at the same time, as opposed to if you had one team out there that go up, take pictures, come back down, walk around, get a lot more done when you're using autonomous systems. The lower left-hand corner is Army Corps Levee out in the Tulsa district. And again, here they wanted us just to give them a degradation report of the levees. Well, we decided to go ahead and go up and do some anomaly detection, as well as RGB imagery overlay, so we could show what they built. That levee was built in the 1920s, and we could pull up that as built and put it into AutoCAD and put it right next to our engineered imagery pool based on the drone flight. And next up is the artificial intelligence and machine learning engine. So on this one, first the final piece of information in terms of autonomous systems are acoustic and vibration sensors. So this one's really interesting because when we're talking about digital twin, we're not just talking about a campus or a building or even going down to the component. So here we're showing this inside of a boiler room, and each piece of equipment, and let's just use the HVAC. We all use an air conditioner when it was summer. You know, you don't want to get hot at your house, at school, wherever. There is a acoustic signature to that HVAC, to that critical infrastructure, almost like a heartbeat, like, you know, going up, like it could be a humming. If you can tell the machine that this specific piece of infrastructure should have this acoustic signature, and if there's anything that deviates from that, if there's any change detection from that, let me know. That would be really helpful for a public works, an HVAC inspector, a facilities manager, to be able to do preventative maintenance on equipment and not just the specified maintenance from the manual. So let's say there was a rusted bearing, and now that HVAC unit is making a hiccup, or it's skipping a hum, or it's higher in pitch or lower in tone, or you're hearing a clanging. So whoever that facilities manager is could have their phone, and the digital twin would just send them a notification. Something is off at this piece of equipment, and they could deploy people out there to do preventive maintenance, potentially fix one part before the entire thing goes down. So think of all the systems we have right now where we check them at certain times, but if we had real-time, ongoing, consistent listening or learning of machines, we could potentially extend the lifetime of those different critical infrastructure. Next is the artificial intelligence and machine learning engine. And on this slide, but that wants to load. This is now showing you how we are doing analysis on top of the information that we're capturing. And I'll work left to right on the top. So for construction monitoring, this was an interesting project that they wanted us to help with using. They wanted to use artificial intelligence, machine learning, to help them stay on track, to help the construction schedule. Fine. The construction company provided some information. They said, we're going to be pouring the concrete on this date. This is a 12-story building. We should be on story 6 by this date. We'll be using these pieces of equipment. We were able to then put a fixed mounted camera and have already given it an algorithm to identify different pieces of equipment. The blue moving around up there says crane in use. The yellow also says crane in use. The green one, that square there, is talking about a concrete truck in use. Literally, there's a camera there that can identify what's going on. So we've also fed to that camera, we should be on floor 6 by week 24, and the camera is showing, okay, we're at floor 3 or we're at floor 10. I mean, you can already begin to do some scheduling adjustments or some notifications to the developer, like we're ahead of schedule, we're behind schedule, even potentially for security purposes and surveillance after hours. These cranes should be here, here, and here. Trucks should be here, equipment here. If anything is moving, again, the camera detects a change. We can then alert the authorities or send out, a text to the security team. So again, we're using sensors and analysis to then help us solve problems, get decisions faster. I think another great one to showcase here would be our ICS inventory at the bottom in the middle. So right now, for control systems, they usually go into boiler rooms. They have their tablet. They're looking at RFIDs. Okay, this is serial number. Okay, great. Take a picture. Okay, this is supposed to be here. That's supposed to be there. Now we can go in with an iPhone, and we've put an algorithm on that video feed and can literally walk in and begin to do inventory and analysis inside of different boiler rooms. On the right at the bottom is component condition. That's relatively new. But using thermal sensors, we're trying to identify if different pieces of equipment are hotter than they're supposed to be, or they're giving off a heat signature that's over a threshold. So suppose you have to go up to each one and hot to touch, or or shut down the whole system to begin to do some of this critical component inspections. You can begin to do it while you still are in your on time in regards to some of these facilities. All right. Upper right-hand corner, I talked about on the edge or on edge computing. This is kind of showing what it would be like for a facilities manager, and that's a HVAC unit. There's a problem, ventilation error in system 5. So naturally, these different systems will be checked again at a frequency. It could be once a month, once a year, twice a quarter. This is trying to put the maintenance and the need for maintenance at specific times into the user's hand. This could potentially save a lot of manpower hours, and or just make it more efficient for people in the building at different times. I think another interesting one to note here would be our enforced field drone detection. This is, so if we're putting fleets of drones in the air to begin to do additional data analysis and data capture for our facility condition assessment, roof assessment for insurance companies, during emergency response situations, even during the floods. I mean, they've had different police departments and fire departments and EMS using drones to see where people are, who needs to be reached, who needs assistance. Sometimes you do have bad actors that put drones in the air as well. So the enforce field is then using also machine learning. This is a camera, and it is picking up different signatures. So basically, like your car has a license plate, drones have ways to identify what they are in the air. They're giving off a sense. They're giving off an identifier, a digital identifier. So if for some reason someone put a bad actor drone in the air with enforce field, it could basically send out an electronic that would take it out or take it down. So that's also kind of interesting as we begin to put more autonomous systems in the air. You want to make sure the right ones are up there and not people that are, trying to do things that are possibly illegal. I've never briefed from Excel, from Solid 4 before. So this is a digital twin. This is now that we've brought it all together. And I wish I could enlarge my screen, but I cannot. So I could switch to a PDF, and then it'll be the full screen, but then you're not going to have any videos. But that's okay with you. That's okay with me. Hope you guys can still see this okay. Okay. So, and again, we can send the videos, no problem. Upper left-hand corner, we're just showing a utility system. We were able to build out the entire utility system for Tinker Air Force Base. We did some node analysis, and we're able to basically show if there was a single point of failure on that base, or if we were to flood the base due to a weather event, where should we not have our backup generators? Where does the base flood first? West Palm Hospital, we basically built out the entire hospital in a 3D space, and we're able to go through and identify when we should do different plumbing checks. A big issue right now in VA facilities is plumbing, and they have different waterborne diseases inside of VA hospitals where you're supposed to go and get better. People are getting sick, so they're beginning to identify, like, where do we have these Legionella, is what it's called, that waterborne illness. Where are we having people saying that they're feeling sick, or we're seeing brown water, or the water tastes funny, or looks funny? And then we can begin to just do some analysis. Okay, this is the water feed that goes here to this level, or we've had 25 complaints here at this spigot. So it begins to help tailor for the few manpower they have at those different bases where to deploy people for bringing things back online. Okay, this one. Next one for digital twin, I'm showing some pictures here in regards to augmented reality and support maintenance. So if you have different critical pieces of infrastructure and you have this huge binder, and you are looking through to see how it all works, how to learn to use it or fix it or troubleshoot it, we decided we would build out some of these pieces of equipment in virtual reality. So junior journeyman, if you're first day on the job and something goes wrong, or you want to train before something goes wrong, you can put on HoloLens glasses and see the critical piece of infrastructure in front of you, but also see on the job training, like in your same screen. So it could be saying to get a certain wrench, press this button, turn this valve. So again, something you could do by going back and forth to a book and looking at a video on YouTube, but if you can do it on the critical infrastructure itself, that can potentially close your learning gap more quickly. The hospital planning and human performance use cases are quite applicable now in this new COVID space. The VA is actually planning on building some new facilities just to make sure our retired or men and women of service are not having to be in such backlog. So we basically built out a hospital in a gamified arena. So think about like Xbox or PS5. We built a hospital, we put droids in it that were people, and we put other droids that were a hospital staff, doctors, nurses, security. And we were able to see how many patients are able to be serviced each day, each 9 to 10 hour day, if we have this many doctor's offices. what if we reconfigure the waiting room? What if we put more chairs? What if we put more doctors? What if we take out the break room? So we could basically, with cost, price out how to build the most cost effective and maximize efficiency of a different hospital floor. So right now, you just put out a bid, someone build me a hospital, and they build it because they've built thousands of hospitals. But now we can actually go to the builder and say, actually, no, these are the specifications, because we know we'll be able to help our airmen and women. This much percentage more people can be served in a week if we build it to this specification. In regards to human performance, that video is showcasing as we return back to work in this new environment. That's actually for an EPA lab, and at EPA labs, you have to be clean to a certain accountability measure. And this basically walks you through what cleaning aid to spray, what cloth you should be using to clean off different surfaces, how much time you should wait for that spray to either evaporate or to additional sprays. So it sounds a little, I'd say elementary, but as we go into this, as we're returning to work during COVID, that's not going anywhere. We have to make sure that these different secure EPA labs are staying up to the assured cleaning necessary for that job and mission. And finally, the feasibility studies. And here we're just showing that the Air Force, Army Corps, National Park Service, and our commercial teams are confident in this work to the point where they're asking for publications for the different engineering, recovery, planning, and resiliency work that we've been doing. So I think a cool takeaway probably from this slide would be the Navisworks Freedom Training Guide. That was that VA building that we did for the plumbing in regards to the Legionella outbreaks. They enjoyed that product so much, they were like, can we give you guys another contract so you can potentially do some trainings for us so we can know how to use it and we can deploy it out to our other facilities. So that was kind of just a testament that they realized using technology, not staying with the conventional measure, was hand over foot a better way to execute and to support that mission. I'll talk through, I think I have 3 case studies, and then I will stop talking. Let's see. I want you guys to be able to see the whole thing at one time.
If you need to go back to the video, please do.
Well, no, I'm okay. It's fine. So this is just a deeper dive when I was talking about that Tinker build out. I think it's important to note what the power of using computer applications to do. We were able to do node analysis. So we use artificial intelligence to do modeling on the different nodes on the base. And we were able to identify there were 97 of about 9,000 nodes that were single points of failure. So if this goes down, like, we're out. We can't get past this one point. To get to that calculation, it required almost 10 million recursive calculations, and we did the math. Each calculation took us 5 seconds, and that would have taken a person over 4 years to identify every critical node on the installation grid. It took our group, we were there for, I think, 3 weeks. So again, we're just trying to showcase the speed and using technology. And just for the awareness of this class, what you guys are seeing on the screen is InfoWorks 360 up here, and these are AutoCAD Revit models down on the right. This was that Legionella I was talking to you guys about. I think the most interesting thing here would be the thermal imageries to map the pipes. So right now, if you had to go into the boiler rooms or the plumbing rooms of these facilities, you literally reach your hand up and figure, okay, is this for hot? Is that cold? We're using computer vision and thermal imagery as we're walking along with the iPad to identify, okay, hot water pipes, cold water pipes, these pipes are out of service, and just confirming what it is we already know to be in the as-builts. This is really important for older buildings as there's been renovations over time, or as-builts were lost, or management's changed hands. So again, we're using different thermal imaging to identify concealed mechanical and plumbing systems without the need to go inside the wall. So it's almost like you're looking through the wall like Gumby, which is pretty cool. This one here is a Hurlburt Field. And basically what we did here, the picture in the middle is basically we rebuilt this to engineering grade specifications using a LiDAR scanner. You just hold in your hands, called pyrocosm, and we walked the base, or we walked most of the buildings, 43 buildings at this base. in 7 days, and they've given us 6 months to complete the project, mind you, because again, they didn't even realize what technology could do for them. So, every turn they're like, wow, like this is, so fast. And we were able to then compare that back to the as-built drawings, which is on the lower right-hand corner. And even we're able to showcase to them, hey, just so you know, like you do have additional structures on this installation, or in your as-built, you're showing that you have these beams in these places. That's not right. So now you need to go and adjust your emergency response plan, your emergency management plans. So this was a really great thing for the federal government. They asked for a 20% inspection. I think we were able to do like over 90% of the buildings for the same cost. And I'm not going to do that one. So that was a little bit of my presentation. I do have a quick video I could show as well, if that is okay.
Please go ahead.
Okay, awesome. That I can actually show the whole screen of just a video. Okay. All right. Just going to show some of the use cases so you guys can actually see the videos. They're not the coolest part, but they're very compelling. This is the advanced rapid energy model I was telling you about. This was actually recognized in 2018 as an Association Defense Community Innovation of the Year. Again, they were truly impressed. We were able to do so much analysis in such a quick amount of time. This is that same base. And now we're just doing some click-throughs, showing the information. Fuel tank analysis. Right now they do fuel storage by checking logs to see how much fuel is in there. Yeah, oh yeah, it's 90% full. We're like, no, sir, it's 50% full. So you either have a leak or someone's stealing fuel or what. So we're even be able to help with savings and efficiencies at the fuel farm as well. Upper left-hand corner, we're doing some water simulation, some rain simulation in the event of a flood. And again, that's using Autodesk software InfraWorks 360. It's also showing the gas lines, electrical lines. This was the Army Corps. I talked about that Levee Inspection where they could compare 1920 drawings versus drone flight to this date. So you can actually see the degradation. You can see the shift of the levee. Right now, this is done by people driving in vans with cameras face on the ground, taking pictures. That's a conventional way you do a levee inspection to date. As you all know, with the hurricanes in the Gulf, especially in Louisiana, like levees are a very big part of that emergency managed response for hurricanes. And you can literally go and prove and justify to the Army Corps, to a mayor, to an emergency manager, like we need funds to fix this because this is not only the wrong height, but it has sod degradation. There are people leave their cars out there, their mattresses out there. It's not a useful levee. And that can be very clear just by using computers and computer vision and LiDAR scanning to justify those types of financial requests with the same engineering accuracy. Maybe I should have started with these videos, but these are not as up to date as the briefing I gave. Talked about sensors, this one, but now you can actually see what I'm talking about in regards to a normal spectral signature, rusted bearing, and balanced. And every time it happens for the machine learns what it's listening for. So they cannot just say, this is abnormal. Well, once you go and see what the abnormality was and you say it was rusted bearing, you tell the machine that. Now the machine knows what rusted bearing sounds like, what loose screw sounds like. So it's very interesting as opposed not to having someone just standing at a component looking at it 24/7. This is the pavement condition. And basically we've taught the drone, taught the machine to identify creaking and cracking. This is quite useful for the Air Force, as obviously they have lots of airfields, but also the FAA, so the people that manage all the airports that you fly out of, that we used to fly out of, are beginning to use this for their pavement condition assessments, which is a requirement, obviously, as you're taking people in planes, they have to land. The quality of that landing areas is a huge insurance liability, so that's really useful. This is where we're showing that LiDAR scanning. Again, we are rebuilding this National Park Service campus to engineering grade. That upper right-hand corner is kind of showing you what we captured and what we rebuilt out in Revit, kind of side by side. And we did this 7 times more quickly than the traditional methods. Talked about that. This one's kind of interesting. Again, I know, it's a lot of LiDAR, but LiDAR is just, it's a really unique and very efficient way to capture data. But the National Park Service is going to begin to do some of these drone flights for some of their more degraded buildings. We didn't even know the National Park Service is one of the largest landlords, like in the United States. They own a lot of property on these different national parks, and they're going to begin to use our group to scan some of the buildings that are beyond repair and that are historical landmarkers, and implement like a virtual museum type of platform where people can still be able to visit these historical markers and parks, but not have to put anybody at risk or in danger. So think about like Redfin, when you can click and go through a house and see if you like the tub. Very similar here for the National Park Service for some of their more degraded buildings. We talked a little bit about this. You guys can see a better picture. Fixed camera imagery analysis. And this is that facility planner I talked about as well. And I'll end on this one, but just so you can see, it's in virtual reality and you're watching it like you're playing a game. And this is completely before. This is during design you do this, not after the fact when everything's already in place. Now you got to go get a contractor to remodel. We literally did it in virtual reality using the Unity platform gaming system. All right, stop. Great. With that, I will open it up to questions.
Okay, that was excellent. Thank you very much. If I can drive the first question, if any of the students want to be connected, you have to, on your screen, you can request or send me an email. I can bring you in person. But one question I'd like to bring forward to you is, how do your degree is in environmental policy. Much of your work is in technology, future technology. How do you bridge that gap between public administration, public policy, and the title you gave was smart ecosystems? How do you bridge those gaps?
That's a great question. How do I bridge the gap? I think the most important thing to remember, regardless of my major, environmental policy, this is really just about solutions. If there's a problem, are there tools, techniques, and tactics that can provide a solution? So starting off at Boz Allen in environmental policy, I was doing trainings, environmental liability training, using a system. It's called RACER. It's a cost estimating tool. That was pretty straightforward. If there is a contaminant in the ground, you need to dig up 50 cubic yards of dirt, haul it away in the correct hazardous waste vehicle, and put new dirt. So it's a really simple solution. As I continue to work with Boz Allen and with different clients, I felt, more comfortable, and I also was kind of staying up with technology that I would just, this report makes sense. I think it'll be easier if we had a map. And I think the map was probably the gateway for me to get into more innovative technology and solutions. I was just doing, again, environmental sampling. So there's sample points, there's well water points, the base is inside of this square box. This is all just in a report. We were not using maps. We were speaking it all. We were reading deeds. And I said, well, here, I put in a map really quick. Let's take a look at it. How do we feel? And it was just easier to have conversations with clients, comfortability with pictures opposed to words. It is amazing when people are kind of intimidated by a 100-page report, but they'll talk for an hour just in front of a map, pointing at things, zooming in, zooming out. You're a lot more interested in it. So I think the environmental policy, I guess, kind of got my foot in the door. But I was just trying to think through what could make this easier for my clients, maybe maps. And maps kind of was a platform pushing it into sensors, drones. How can we make maps more quickly? How can I use a map on my phone? I just put it on, on a PowerPoint or on my computer. So I think that's what bridged the gap was we are getting paid to provide the government with good ideas. So I couldn't just stop with, well, I know about policy for the environment. I had to just think of other ideas and kind of get smart on them. So that encouraged me then I didn't get my master's until I was like my 5th year at the firm. It's now my 11th year next month. So it didn't become clear to me that I should probably get this GIS stuff going pretty good because I was getting more requests. Sophia, what if we did a map? Now they're telling like they thought of it. What about a map this time? Even though I kind of like always like pepper in the idea. And before I would pull up Bing Maps back when Bing was cool, right? And like Axe Jeeves. That I would just pull it up and like, well, let's just go to it and see if we see anything. And then obviously learning ArcGIS, the different tools. And now think about the facility planner I showed you, ArcGIS indoors. Even companies are coming through and they're seeing there's a need for this solution. ArcGIS originally was just doing what? Like, this is the Sahara Desert. And these are all the parks in the United States. And now they're doing, this is the hallways of an intricate bank. Maybe that's closed or like a historic site or a pyramid. I mean, there's ArcGIS indoors. Like they have literally come down from the globe, which is what they were doing originally, to let's go into this confined space because that's also a spatially referenced area. I hope I answered your question.
Okay, good. The interesting enough though, you speak of ArcGIS indoors. You may remember Dr. Henson and myself at Texas Southern in 2011. We proposed a grant to fund an indoor application. Had we been smarter or had the money to start off, maybe we'd be making those millions of dollars because no one was doing indoors at that time in 2011. So again, my students are all in a variety of public administration fields. I was hoping you will talk about a little about thinking outside the box and addressing problems and learning, not only depending on the degree to give you that intelligence, but using the intelligence you already have and also using the resources out there to gain some of this intelligence and to be more, not more useful, but more marketable, so to speak.
Sure. Well, I think the key word there you said was marketable. I think if I didn't get my master's, I probably would still be, well off or okay here with the firm. But some of the things that I think have really elevated me or provided me with a larger platform, one is my willingness to say, sure, I can do that, knowing I'm going to have to probably work a little harder to figure out what exactly they want me to do. But even just little certifications and classes on Coursera, Udemy. I've done one of the LinkedIn learning classes before, but I primarily have done Coursera. But now, even being within the firm, we have a huge vault of trainings, and they go kind of unused. But every year I sign up for a consulting 101 class. I mean, now that I'm a lead associate, we have like some higher level finance classes. But I never just took my job like, okay, I'm the environmental policist here. Let me sit and crank out my environmental policies. I would always sign up for extra training, and usually those are not on our paid time. But I found it really valuable going to public speaking courses. I just finished a business development class literally last week. 2 months ago, I did a Power BI course, a 2-day class. Again, it's on my own time, but I've been able to showcase a dashboard, and I could pull it up here. It's just classified. But it is so incredible, the engagement I get from our stakeholders by using a dashboard as opposed to before I was using this really long spreadsheet, which had all the information I needed and answered all the questions if you had one. But the dashboard, people were just like more interested in, it's the exact same data. I changed no data, but now it's visualized and very easy to slice by market and look up by customer journey. And I didn't know Power BI until I like saw something on YouTube, and then I went into our vault of training and noticed the firm pays for a full 2-day class on how to do Power BI. That's nothing to do with GIS. It's nothing to do with environmental policy. It has to do with me wanting to make my clients more comfortable with my solution, more comfortable with what I'm saying. I will say any given day, I rarely talk about the environment. I just don't. I do not use GIS anymore. I hire people to do that now. It's as if I never had the degree. I had a gentleman, he just went to Microsoft, doubled his salary. He was with Boz Allen for a year. He left because we couldn't match what Microsoft's offering. He learned how to do GIS over the weekend using YouTube. I have a master's. I needed him to make some maps for me for a client. I could have done it myself, but I'm like, you know what? He's smart. Math major from Texas A&M, gig him. He came back on Monday and said, is this what you meant? One, I hate that I still pay Johns Hopkins University for my very expensive degree. And this guy was like, yeah, I saw some trainings online and just kind of like tried to follow that. He, from that day forth, was my GIS guy. He has no GIS degree. He showed me a product and he justified he could produce said product. And he said, I use YouTube. And that was totally fine with me because it was a great product. It was received well by the client. And he didn't have to go back to school and get another degree. Like it was really fantastic. So I think, again, just kind of going back to being marketable, it's a willingness to go and figure something else out, getting smart at things that make you uncomfortable. Or if everyone keeps saying dashboard, 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 go figure out how to do dashboards. Don't be the one just saying dashboards. That's not helpful. You're not going to be of any value to anyone if we're all just looking around for a dashboard. Go make one. And then you become invaluable all of a sudden until there's this other hot word and you go figure that out. Or you can hope that you keep failing up. And I'm not sure the demographics of the folks in the class, but if you're a woman, if you're of color, if you're not the same political inkling of your professors or your leaders, it's hard to just fail up. Things don't just happen for you. You have to do a little bit of extra. Go ahead.
Okay, let's see if there's any questions. Anyone has a question on the chat? If not, I have a follow-up.
I don't know what. Oh, marketable. Okay.
The interesting of the last week in preparing for you being in the class, I believe I share with the students our Power BI platform at Texas Southern because we run all the data. We discuss the big data at Texas Southern. We manage much of that data on a dashboard, which is publicly available to everyone. And I believe it was last week we went over it. And that's when a light went on to me to contact Institutional Effectiveness and ask them a question. I mean, can I get the software for Power BI to find out that we not only have the software, but we have all the training? So those are the Excel and Power BI is two elements that's been added into our class because I really want my students, I'm sure most of them, many of them would be graduating in a few semesters. And if we can spend some of our time, besides writing some papers we will write, is in picking up some of these skills. And interestingly enough, if you go through the Lincoln piece, you get like a badge or a certificate each time you do it. So that's really good thinking. Anyone has a question for me or for Ms. Rodriguez?
Any question you can throw. It didn't have to be what I talked about. Go for it.
That's the one thing with Webinar Jam. It's not Zoom or, it's either chat or they have to raise their hand. This is really meant a lot for when you have sizable audiences where you can't put them all together. But again, so you spoke of the GIS. Would you recommend, because I have asked my students to get a global account and go to Esri, go to the big data. I mean, like, for instance, like the free data sources, I've mentioned to the students, could you mention some of the publicly available data sources, and there's one comment. Let me just read it. I can appreciate the sparks that go off out in my head to think outside. That is Miss Robbins' statement. I will have to read it. Not a question, but I can appreciate the sparks that go off out in my head to think outside the box. Very interesting.
Yeah, I
Hopefully.
think. Oh, go ahead.
No, you go ahead.
Oh yeah, I was able to pull up the chat, so thank you for that. I think, I mean, in reading what you wrote, Robin, not a question but a comment, and I appreciate it. One thing I would say, and I would encourage all of you, is to think outside the box, or at least understand what the box is and get comfortable with stepping outside of it, being a little bit uncomfortable. I think one thing that really can hold you back. I remember when I started on this project, I was frustrated. I don't do this. Like, what in the world? And now I'm supposed to sell this to people. I don't even know what it is. What's machine learning? I said machine learning for dummies. There's a YouTube. There's a guy who talks about it. I read a book, or you know how you can a Flipboard. It'll tell you how many minutes the read is. So like I would do like a 2-minute read, a 3-minute reads, enough to be dangerous and get comfortable. Obviously, when I need help, I would bring someone who's smarter than me into a conversation. But I would continue to make those connections and network. And if I know, again, it's those hot words. Machine learning is hot right now. Dashboards are hot right now. So you should be able to drive a conversation towards those things, because people are going to be like, oh yeah, I saw something on TV, or oh yeah, I would love to see that sometime. It's just really important to go there, even if it is something that you're not completely comfortable with. Now, don't lie, because that will get you in trouble. But you can get enough information at your fingertips to be dangerous and to hopefully elevate your platform. Mr. Afhanmi says, I know a little bit GIS. Okay,
So,
well, you can learn a lot more. I know having an education license does not approve. Well, yeah, learn more. Not a problem. You can learn a lot more by using all the trainings. You guys have education GIS licenses, which means you get access to every training with the Esri Access program with y'all's maintenance license. So the things that I would have to pay for, like you get all for free. So even just putting together a learning plan, which I did for the new products, ArcGIS Indoors. They have a military extension that I had to learn about for my clients. I just would take the trainings or watch the videos or even see the end product and just see, okay, so I know that this is doable, and I can maybe find someone to help me do it. So I think it's okay if you don't know a little, or if you only know a little. There's so many resources that you could know so much more, or at least be grouped or coupled with someone who knows more than you that can bring you up to speed, depending on what it is you're trying to do. Does the technology replace or complement technicians and mechanics? This is definitely a compliment. That's a really great question, McNair, Mr. or Mrs., they or them. I think it is so critical to understand that you are freeing up a mechanic and technician to do something that's more important. A mechanic or a technician or a SME or a level 5 should not be like turning a screw and like doing like checkups on things. You should be teaching. You should be bringing the junior people into like with your knowledge, your institutional knowledge. I really don't think I don't think insurance assessors should be on your roof taking pictures of your roof. Why? Because they could fall off and die. So use a drone and do it. Stay down there on the ground and make sure that there's a drone up in the sky. I think this is definitely a compliment to that. This is not in regards to replacing. Now, I will say we have they're putting dogs out into the field in Iraq right now. Yeah, and by dog, I mean robotic dogs. They have dog robots with missiles walking around the danger zone, firing off at bin Laden. That's probably a better thing to do than putting soldiers out there with guns and reaction time to try to get a person. Blow the robot up. And we, people, can stay back and do more of the critical to the mission efforts. Or we can do more of the game planning. We can do war gaming beforehand. So I think that's something to really consider, that machines are amplifying our time to do other things to hopefully continue to move everything forward. Great question.
Anyone else? Well, as we cover another question, part of the game plan I think we can employ to what we have done this semester to share with you, rather than use I couldn't find a textbook first of all to use. So what we've been doing is basically reading from folders. These students have been struggling through my archaic way of forcing them to do things. And I know you, Ms. Rodriguez, knows about that a little bit. You know, I ask a question one way, but it's not necessarily the only question. The answer could be many to force you to think. Because I think part of what we have to do right now in the space we're in is to, as you said, let me put it this way. Problems are solutions in transition, and it is spelled opportunity. This is the approach I want most of the students to take. That when you see something, it's not like, I can't do it. No, it's like, okay, what is it? Let me try it this way. Let's try it that way and collaborate. Call one of your peers up. Test it, because that's what we're living in right now, the testing kind of environment. Right now in the School of Public Affairs, I'm really hoping that these few students we have here in this class, like I think it's 8 students, I'm really hoping that at the end of the day, they learn some key points in Excel, maybe Power BI, and just some in thinking. You know, thinking how to think, how to always seeing that there is a solution.
Okay, McNair, what about invasion of privacy in regards to predictions, probability of human behavior? Can you write more? Do you mean what?
Well, I think he's referring back to we were just having a discussion about TikTok and the notion about how TikTok is moving. So that might be some of it.
Like a polygraph on steroids. McNair, you write like a deep agent, P.S. But that's okay. I don't know. I don't know what you're. So, well, for one, I can talk about what it is our solution does, and it's really in regards to facilities, infrastructure, and utilities. This group is doing very little with human behavior. I mean, we did show the drones. Yeah. Okay. Great. AI cameras and analysis. Right. So, I did have another video you guys didn't see, and it was like pixelate, and yeah, I can identify a person, but it can't identify what person. Again, we are using training images of tractors, ships, planes, guns, missiles. We're not to the level of solutioning to do we're not facial recognition. There is a group that does that. And yeah, they are, yeah, you said it yourself, facial recognition. Yeah, that's not at all what our group does. I'm trying to recognize if there is a faulty roof or a crack in the pavement. So, I mean, my feelings of the invasion of privacy, I mean, if I'm being completely honest, and this is just Sophia talking, not at all